Hello friends, myself Arunava Sarkar. Uh, I would like to teach you about the aromaticity, anti-aromaticity and non-aromaticity or those compounds on the part 1 discussion of today. This is really a very important topic as you probably have gone through the previous year's JEE Advanced, that is IIT paper questions, where you can find that in integer type questions they will give you a lot of structures and will be asked to find out which one is aromatic or number of aromatic, number of non-aromatic or number of anti-aromatic compounds. There can be some more diverse part of this type of questions. It can even come in single option or multiple option, and especially those who are the medical aspirants, their aromatic part is mostly very important. So let's go for this and think about how to deal with the questions which are based on this particular topic. First we are going to have the part 1 discussion today. Next we will go for a advanced level discussion which will be in part 2. So whenever we are talking about aromaticity, that is the aromatic compounds, the first compound that comes in our mind is undoubtedly our very own benzene. Okay. So I am not discussing much about resonance. You probably know that resonance is concerned with delocalization of electrons. Now, which electrons I am talking here? This can be a pi electron. Mostly you will find that it is written as the pi electrons, but I believe that it is not only the pi electrons, it can also be the lone pair, or it can be the electron pair due to the negative charge. Due to the negative charge. So first of all, what we call as aromatic. Now, you know that in the ancient time, aromatic compounds basically refer to those compounds which had good smell. That's called aroma. Okay. So nowadays we don't stick to this definition and we talk about aromaticity. We talk about aromatic compounds in particularly that fashion which emphasizes on the stability of a particular compound. These are extra stable. If you see the benzene and if you believe that it has come from cyclohexane, which is the saturated part, partly saturated part of the benzene. Why I am saying partly saturated? Because here double bonds are not present here, double bonds are not present here, but this is also unsaturated because of the presence of a ring. So if you go for the DBE of this, that is double bond equivalence of this, it will be having a double bond equivalence equals to 1. Whereas this benzene will have a double bond equivalence equals to 4 because 3 double bonds are there and 1 ring is there. So this is going to be extra stable. Why it is going to be extra stable? This is because you can delocalize the pi electrons of this and therefore it will have a lowered value of energy which is nothing but a resonance energy, that is Re. So what is resonance energy? Now it can gain some resonance structure or resonating structures and therefore it will have a lower value of its energy which is known as the resonance energy. Okay. So what makes us capable to identify whether benzene is aromatic or not? So basically I tell my students to go to the checklist, some of the checklist. So checklist for aromaticity. Checklist for aromaticity or aromatic compound. So number 1, as it is very obvious that the structure should have a ring structure or the cyclic form. Definitely it is a first point and it will be definitely valuable for all the other cases. So should it be cyclic? Number 2, it should be a planar form. It should be on the plane. Like this board is a plane, is a 2-dimensional plane. You can have all the ring forming atoms. That's the most important part. Ring forming atoms should be present on the plane. Number 3, which is probably the most important one, that it should have 4n plus 2 pi, or as I said at that time, it should have 4n plus 2 delocalizable electrons. It should have 4n plus 2 delocalizable electrons. Something that can delocalize. It is not present on a particular fashion. Like if you talk about this pi electrons are localized now. It cannot undergo a rotation within the ring. So this is 4n plus 2 delocalizable electrons. And what does n signify here? Please understand, as easily we are talking about the n. Basically it is found that we write n is to be 0 or any positive integer like this. But my dear students, there is a very good specificity and validity of this n, for which we have to discuss about the HOMO-LUMO concept. Highest occupied molecular orbital or lowest unoccupied molecular orbital theory in the benzene bond formation, which definitely I will try to discuss in some subsequent lectures. But for now, we will assume that this n is nothing but a 0, or it can be the positive integers. So, if I think about this, and you must know that this is known as Huckel's rule or Huckel's rule. So if I go with this, then we must say that the benzene is planar. Also you can understand the hybridization of this, all are sp2, all are sp2 hybridization. It's planar, it's cyclic, and you see it has 6 pi electrons, which is 4 into 1 plus 2. So it is definitely validate 4n plus 2 pi electrons. So definitely benzene is what? Aromatic. So this is the first checklist for aromaticity. Now we will undergo the next part of this, which is anti-aromaticity. To understand this is the first understanding that these two remain the same with the previous one. In the previous one, we had benzene, where it was cyclic and planar. Anti-aromatic compound, this is also cyclic and this is also planar. The third point is again important here. It should have 4n pi electrons, or you can say also it is 4n delocalizable electrons. So 4n pi electrons, it is not 4n plus 2. So Huckel's rule is not applicable here. That's the most important checklist for you. 4n pi is that where n again can be start from 1 to, I think you can understand that no validity for 0 here. Because if it is 0, there is no question of coming to the antimaromaticity or aromaticity or non-aromaticity. Those are not of any point of discussion, but it can start from 1, 2, 3 and it can go, so on and so forth. So this 4n pi will have the anti-aromatic flavor within the compound. The most important part which should be added as an annexer to this point number 3, which is, if it has to be anti-aromatic, please understand complete delocalization is possible. Complete delocalization is possible. This is the most important point. The complete delocalization is the most important point. Whereas, why I am saying this is important, whereas if you go for the non-aromaticity checklist, if we go for the non-aromaticity checklist, definitely again, as I told you earlier, it has to be cyclic. Number 2, it has to be planar, but in these cases, please remember, a non-planar formation is also possible for non-aromatic. We will talk about this. That is very important. That is cyclooctatetraene is a compound where there is a non-planarity, but still that will be made as a non-aromatic one. So planar and non-planar both are actually applicable here, because even if there is an exception, that can also be incorporated in the form of a rule. It's a general statement. And number 3, it also has 4n pi electrons. It also has 4n pi electrons, but please remember, complete delocalization is not possible here. As I told you, the most important part of this is complete delocalization is not possible in the case of the non-aromatic compound. That makes a significant difference between this non-aromatic and anti-aromatic compounds, because you see that 4n pi remains almost same here. Planarity is maximum cases you will find the non-aromatic compounds to be planar. So planarity also resembles to each other, and cyclic is of course there. Then what makes them different? What makes them isolated or isolable from each other? That is the only part, that here we have a complete delocalization, and here please do understand we do not have a complete delocalization. Now any theory or any lecture is really insignificant if we do not have any examples substantiating what we are talking about. So let me give you an example. Let me give you an example of this compound. So how can we name, my dear? This is 1, 2, 3, 4. So this can be thought as cyclobuta 1,3 diene. This is the UPAC name of this compound. It's a cyclobutane, and then it has been made into dehydrogenation, and therefore there are 2 double bonds possible. Think about it. What are the first checklists that you are going for this? Number 1, it is cyclic. Yes, it is. Number 2, it has 4 pi electrons. So a 4 can be written as 4 into 1. So that is 4n pi electrons will be validated here. 4n pi electrons will be validated here. So now the question is, definitely what we can be assured that this is not at all aromatic compound. So one part is assured, it is not aromatic compound because it's not undergoing Huckel's rule. That is not 4n plus 2 is not possible here. So it's 4n pi electrons. So if it is 4n pi electrons, then the next checklist is what I told you at that moment, that when there is a 4n pi, the question comes for non-aromatic or anti-aromatic. So what makes us possibly think about the part whether it is non-aromatic or anti-aromatic, that is whether complete delocalization is possible or not possible. So what is that? That if this moves toward this, this has to move toward this. So you do understand that we definitely get this conjugated system to undergo a complete delocalization, because this has interchanged their position. The name still remains the same, because when it is change the position, you can take this 1, this 2 and this 3, again cyclobutane 1,3-diene. That's not going to be differentiated. The problem is whether it is delocalizable or not. Yes, it is. And those who are skeptical about how resonance is taking place, you can think it about as in this format, that this bond goes here. Please understand here that this gives you a negative charge here, and this is a positive charge here. So in order to balance the positive charge, this bond will come toward this. That will lead to the formation of what? There is a negative charge still remain here. This comes here, which neutralizes the positive charge here, and the positive charge remains at this position. And after that, this comes here, and that gives you. Yes, this is only for those people who are skeptical about how resonance takes place. I have seen that many people ask that how the delocalization is taking place in the bond formation or bond breaking during the resonance. So that's why I discussed this part. So this is completely delocalizable. So if it is completely delocalizable, so undoubtedly this is going to be an anti-aromatic compound. This is going to be an anti-aromatic compound. Is it clear? So this is how you people must understand. Let me give you another example which will make you quite strong as far as the concept is clear. Concept clarity is concerned. You can take an example of this 1, 2, 3. So think about it. So this is also a ring. Whether this is planar or non-planar, I am coming to that. So first of all, what is the name of this? You can start your naming from any of this, like you can give it 1, 2, 3,